So at this point you already have some experience with factoring. There are several different types of factoring you've looked at, but one of the most simple and most common is when you have a trinomial, meaning we have 1, 2, 3 terms, and this first term out here has a leading coefficient of 1. In other words, the number in front of the x squared is just a 1, so we don't even have to write it, because 1x squared is just x squared. So we can think of this as factoring ax squared plus bx plus c. That's the standard form of the equation for, of a quadratic expression, excuse me. This is when a is equal to 1. That's when we don't see anything else in front of the x squared. And that's the kind we're used to doing the most often, where we just look for two numbers that multiply to give me the c term. In other words, I want, let me pull that down for this so you can see. This is factoring ax squared plus bx plus c when a is 1. So we're looking for two numbers that when I multiply them, I get the c term, and when I add them, I get the b. So in this particular case, two numbers that multiply to give me -8, add to give me +2, would be 4 and -2. And then we can just write it in its factored form by filling in those two numbers in binomials with x. So x plus a number, or in this case we could rewrite that as x minus a number. Plus -2 is the same thing as x minus 2. But that's factored. Now this is something you already knew how to do, so why am I showing you again? Because I want to compare that to what we're going to start today, which is, ta-da, factoring. Same thing, a quadratic expression, and this is the standard form of a quadratic expression, when a is, you guessed it, not equal to 1. This is when it gets a little bit more difficult. It's not that difficult though, especially if you use something called the ratio method, which is a really nice shortcut for doing this. There are actually lots and lots of different types of shortcuts and different types of ways to arrange the method visually, just different ways of looking at how to do this. The one I'm going to show you is my favorite. I learned it just a couple of years ago, and all of my students seem to really like it. So here we go. As opposed to over here, where I had to find two numbers that multiply to give me c and add to give me b, this one starts out by first I have to multiply my a and my c. In this case, a is 3, c is -8. So in this case, that would be 3 times -8, which is -24. Now, we're going to come back and do something very much like that. It's just a little bit different. This is why I wanted to compare these two methods for you, or contrast them. Is now I'm going to find two numbers just like I did over here, but this time they're going to have to multiply to give me that a times c number. In other words, it's not two numbers that multiply to give me just the c. It's two numbers that multiply to give me a times c. So that was the first thing I had to do, was find a times c. Now I'm looking for two numbers that multiply to give me a times c and add to give me b. That does not change. It's still just the middle term for what they have to add up to. So I'm looking for two numbers that multiply to give me -24 and add to give me +10. Make sure you're very careful about the signs. There are lots of possibilities for numbers that work with multiplying to 24 and adding to 10, But with the signs, there's only going to be one possibility that really works, and it has nothing to do with 6 and 4. Have you got it? It's positive 12 and negative 2. Positive 12 times negative 2 equals negative 24, and positive 12 plus negative 2 gives me 10. Now, here's where it gets kind of cool. We are going to pretend it's one of these problems for a second. We're just going to write those numbers exactly the way we would if there was nothing out here in front of x squared. But the important thing is to recognize we're just doing this for a second as part of the problem process. We are not done here. This is not the answer. Okay? This is something that I'm going to move forward from. So for just a second, we treat it like it's one of these over here, and I can just write x plus a number, x plus a number. And so I go ahead and write that out. Then I take care of the fact that it is not one of these. And the thing that makes it not one of those is this number right out front. So that's how I'm going to take care of it. I'm going to take that number out front, and I'm going to set up a ratio underneath each of those two numbers I found that multiplied to give me negative 24 and add to give me 10. Okay, in other words, I'm writing it almost like a fraction, or really just like a fraction. Now, if these two fractions, if either one of them or both of them can be reduced, that's my next step. I reduce it. So in this particular case, 12 over 3 can be reduced. That's 4 over 1, because 3 goes into 12 4 times and into 3 1 time. If it can't be reduced, I don't reduce it. Now, after I've done the reducing process, okay, that's the step, is to do the reducing or the reduction. If I still have a denominator, which I don't here, okay, this is not really a denominator because divided by 1 doesn't really mean anything we need to worry about. Here I do, though. If I still have a denominator, I move it up in front of my x. So this becomes x plus 4 times 3x minus 2. And that's my final answer. Don't forget, you can always check your final answer by multiplying it back out. So let's go ahead and do that. We're going to check, and I'm going to use FOIL, which is just a way I can keep track of what I have multiplied and what I still have left to multiply. So I'm going to do first, outer, inner, last, and then I'm going to combine my like terms, and this matches my original problem. So yes, it checks out. I did the work correctly, and that was my answer right here. Now, I've gone through this in kind of excruciating detail, so I want to just review what we've done and go back and do it a little faster because it looks longer when we slow down and look at every step really carefully. Okay? Because there's a number here in front of x squared, instead of finding two numbers that multiply to give me this and add to give me this, first I have to multiply. So 3 times negative 8, that's the first number times the last number, gives me negative 24. So now I'm finding two numbers that multiply to give me that number, the negative 24, and add to give me the 10, the same thing I would always say they need to add up to. The two numbers I found are 12 and negative 2. And first I just temporarily write them as if it's just x plus this number, x minus this number. Just temporarily write it like it's one of the simple kind. But then I go ahead and I put this number from out front underneath. Reduce it if I can.